So we're going to be simulcasting this, I guess. So I don't know. You're going to mostly see the back of my head, I think. So just quick introduction. Thank you. I'll do another very quick introduction of myself. I already mentioned Informationist and Knowledgent. I do want to point out that basically the last one I have on here that I'm a comic book and Lego nerd, mostly, and I'm also a fan of video games, so that's why I'm speaking here today. Really quick background on Knowledgent, what we do, and why we're here. We're a data analytics firm. Everybody at Knowledgent is an expert in data analytics, whether it be from a project management perspective, so on and so forth. We have three main area focuses that we have, which is strategy engineering. I'll have to look now. Governance and operations, as well as analytics and visualization. So those are basically where we're focused. And we're locked in. And as you may know, those are the three areas that you really need to focus on if you're bringing a big data project into your business. So those are what we focus on. Just a quick, before we get started on the talk, a couple of quick things. One, I'm a video game hobbyist. I do not create video games. I helped write one like 10 years ago. I'm assuming it's a lot different now. A lot of this talk is based purely on observation. So as we go through this, call me out if I'm wrong. Participate if you want to. This is really about facilitating discussion. There's no possible way. Actually, there's a lot of ways that can fill up 2 hours with video game talk. That's not what we're here for. We're here to talk about data as it relates to video games. So let's talk about it. Another quick thing. There was a very good talk, a keynote by Grant Ingersoll. He's the CTO of LucidWorks, and he basically did a talk on video games and as it relates to search. So I thought it was pretty interesting, so I thought, hey, maybe we'd hop on the bandwagon and take this thing for a ride. So, history. Let's set the stage a little bit. 1959, 58, right? It's right behind me. 1958 is basically when the first, we think, video game was created. It was by a physicist in a lab, just trying to do something fun with a computer. That was it. Years later, there was this thing called an arcade, and that's where kind of competition really started. Right? Why collect and use data if it's not for competition, right? That's why we use it in our enterprise. That's why we use it every day. It's for competition. So here's a very early, you can probably almost see that in the back. It's Pong. I'm sure everybody has, show of hands who plays Pong. All right. So we're among friends, that's good. And basically what happened was as the arcades came into being, there started to be this golden age of arcades, right? It's roughly between 1978 and 1982. It was, so we just talked about 1970s-ish is when things got started. By 81, the video game industry had an annual revenue of $5 billion, which is a lot in 10 years. Actually, with inflation and putting all the numbers together, it actually comes out to roughly $12.3 billion. So just in terms of getting something started and creating a new industry, that's pretty impressive and very, very quick. Who has played Pac-Man? It's a classic. It's totally solid. There's a lot to it, right? Not really. What ended up happening was people started to. We're going to keep going.
Whatever holds it wrong, kind of wrong.
That's right. Right. So basically, you can start to play Pac-Man. There are lots of different things going on, a lot of different data sets happening here, right? For one, the point system is pretty solid. It's also very methodical. You get one of these pellets, you collect them all. They're worth, almost nothing. You can see on the far left. There's also power pellets, which turn everything, all the ghosts, all your enemies, into attackable creatures. So you can actually do some defending and some offense. And then each ghost that you attack or eat as part of that process, you get more and more points. So, one of the big things about Pac-Man is you always try to get the high score. There's other ways of collecting points too. Don't forget the little power-ups. These are actually the power-ups with the point values associated with each one. So you can see the key. You see a key, you get it, right? That's how you get a high score. And what ended up happening was, it took years actually, it was very recent, I think 99. The highest score possible was reached with Pac-Man. It's actually 3,333,360 is the top score, and that's with using all the algorithmic approaches, right? Getting every power pellet, getting every ghost, and getting every power. And that's without losing a single life, right? Going through the whole game. I think there's anybody know? I think there's a lot of levels. It takes a lot of time. It takes a lot of patience. The one thing about Pac-Man though, and a lot of people might know this, is the patterns are very recognizable. Once you memorize the patterns, you can play the game and beat it pretty quickly. Yes.
Is that a human achievement score?
Yes. Yes. Do I have his name? I don't have his name. If you look up Pac-Man highest score, he's obviously the first result. Totally, yeah, done by a human. I think it was 99, so it was 20 or some odd years after the game actually came out. So with Pac-Man, very very predictable patterns. What ended up happening was somebody created a game that was kind of like it, basically an enhancement to it. You may know her name. Her name is Ms. Pac-Man. She actually was pretty provocative at the time. I don't know if people in the back can see Ms. Pac-Man on the top of this machine. But basically, it was an enhancement kit. It was called Crazy Auto. When it came out, it was done by a third party. And then Namco liked it so much, the owners liked it so much, that they actually incorporated and created an individual game package around it. The reason why I bring up Ms. Pac-Man, it's very interesting, is that there's actually a competition that is held pretty often where people use AI to actually try to beat Ms. Pac-Man. Basically what you do is you try to make it so that she is avoiding enemies while swallowing all the pellets along the way. And I'm going to do my best here to actually show you what it looks like. Doing a great job so far. I never asked who played Ms. Pac-Man. Everybody? Anybody? Nobody? To a lay person like me, I have to be honest, it's roughly the same as Pac-Man, because I never memorized the Pac-Man, so I don't get the full effect.
The movement of the ghost, is it random?
With Ms. Pac-Man, so in this competition, it's a good question. In this competition, it's actually players that program Ms. Pac-Man versus players that program the AI of the ghosts. So it ends up being kind of a healthy competition. You can actually see in a couple of instances, you can see the red here, and that's basically an enemy target. And she gets confused on occasion. She's not sure kind of which thing to go after. At any rate, the winner of this competition got about 69,000 points. So obviously, there she goes. That's actually it. See, she's getting it's easy. That's great. Should I just leave this on? We actually see it's learning, it's trying to figure out which way to go, which way would be the best approach. And it has targets. Yeah, that's the target. And then obviously red is trying to avoid. I think green is like best possible now. But the idea is with 69,000, yeah, it's all with 69,000 points, there's a pretty big gap between somebody who's doing it and practicing and professional about it, and what you actually get with a machine doing it. at least at this stage. So we spent, I think, enough time going through kind of a couple of examples. So we're going to just go through kind of a much larger, if I can get my mouse over, I'm going to go through a much larger set of games here. Okay. So this is obviously an article from the Huffington Post. It's a little gigantic for the screen. So just in terms of the evolution of the game, so we can, what I want to do is just go over at a high level some of the history and some of the individual games that are out. And then from here we can kind of go into the data. So some more background. Video games. For one, Space Invaders was also huge. Who's played Space Invaders? Pretty much everybody. Okay, great. Just like anything else in that time frame, it was another classic. People ended up spending lots of money at the arcade. It obviously syndicated later, not syndicated. It was available later on multiple platforms, so you can bring it home. Go from there. Another classic, my personal favorite, Super Mario. Who had? Let me ask you this way: who hasn't played Super Mario? I saw did you not? Have you not played Super Mario? I won't judge. You have. Okay. That's fine. All right, great. So the idea is 1985, roughly. This was part of a big revival of video games, generally speaking. This was basically the home console coming back from the times of Atari, where it was viewed largely as a failed system. Moving on. Lots. Actually, kind of interesting note. Speed run of Mario was completed in like under 5 minutes. So it's that's
432, yeah.
432, yeah. I'm impressed. Even it was with the cheats and everything, but it was still pretty good. So Wolfenstein 3D, this was in '92. This was a big one. I'm not sure how monumental it was. I feel like Doom was kind of a little bit above that, in my opinion. But the same type of gameplay that's really started using 3D graphics, improved the game a bit. It was available in 256 colors, which is crazy, right? Major advancement in technology. We'll continue. This is kind of an interesting game. Who's played Myst? I knew I was in the right room. There's more than two, which is impressive, right? Because I don't think it was a super well done game, but it obviously pushed the boundaries of what was available at the time from a graphics perspective. Actually, it sold 6 million copies, so I guess to have a few people in here actually isn't so great. This is an even better one. Final Fantasy VII. Anybody? A few? Big PlayStation 1 game. So I guess we just crossed the threshold back in the console later on. And so PlayStation 1, I don't know if anybody knows the story of Final Fantasy in general. So basically Final Fantasy is a game series now, right? After 7, you would imagine it's a series. The idea is that this company, Square at the time, I think, was going out of business. And their one last hope, their final fantasy, was to create this game that would trump all other games that they've created. And actually ended up saving the company. And so 5 and 6 and 7 later, this game was hugely popular, 3 discs. I played it for over 50 hours, which is a little bit embarrassing now. But there's a lot to do in the game, and it had a lot of storyline, a lot of character development. We'll go into some interesting details about that later, actually. Grand Theft Auto 3. Anybody? Open world concept. Things get a little bit bigger. We're not just playing one storyline. We're basically doing what we want in between completing challenges as part of that. I feel like people have played Halo in this room. I feel like it's true. Okay, great. So again, kind of reaching outside your own environment right now. We're playing with other people. There's floating points that have to be dealt with over network connectivity. There's a lot of information getting passed back and forth between one player and the other, including name calling over a microphone. I don't know if anybody's experienced that. assuming we're all here, so none of us are playing World of Warcraft right now. Is that true? Are people playing? Not in this room? Not now. Have you played before? Maybe no. No, one. People are afraid to admit it now that I started with that one. A few in the back. So this is obviously another one of those things where the network is getting much larger, right? This is for those of you who don't know, would be very surprised. Massively multiplayer online role-playing game, right? So you're actually in a very large community with a lot of people. We'll actually talk a little bit about Blizzard later as an organization, as a company, but it goes on. Madden football. Started in '88. It's so late in this because there's basically been a new Madden every single year since '88. They continue to produce advancements on top of their original gameplay. We'll get into some of the data behind that a little bit later. But I think the most interesting one metric here is probably the number of copies sold. It's a lot. It basically, I think it accounts for a fair amount of EA's revenue. So good on them. They also churn through a lot of talent. Has anybody here worked for EA? Just out of curiosity. I've heard not great things. I was just curious to see who's here. Last but not least, Destiny. Has anybody played Destiny? Who's playing Destiny? Yeah. Yeah. So Destiny is a pretty. I don't think it's popular yet. It's a very advanced game. It's kind of taking that open world concept, applying some storyline to it, and it seems like it's very interesting. Actually, I said it's not really taking off. 88 million is pretty good in terms of different things going on there. Virtual square footage, so a lot of different things going on there. Switch back to the slideshow. Okay, so that kind of covers the larger gaming perspective, but we didn't really talk anything about mobile and all the different mobile games there are. We're going to go through this one really quick, I promise, just to provide again some additional context. I'm not going to go into each and every one of these, but I feel like everybody's played Snake on their phone. Is that true? Has everybody played Snake on their phone? I've played Snake on my phone. Also Brick Attack. Everybody played Brick Attack?
My calculator.
What's that?
Oh, my graphic calculator.
On the calculator. That's fair. That's a mobile game. It's a mobile game. I'm totally for it. There were some issues in the mobile gaming industry early on with Java-based platforms. Not hugely important. I think the more interesting things happened right around 2007 when we basically have these computers in our pockets now, and we can start playing games. We're starting to share data. We're starting to collaborate more. We're actually sharing data in two different ways. One is with other people, right? Words with friends. Come on, words with friends. Everyone's doing words with friends. Scrabble for your phone. And actually sharing that information with the developers of the game as well. So you're getting a little bit of everything. I'm going to go through Angry Birds, huge franchise now. And then obviously the more advanced games. We'll talk a little bit more about Candy Crush later on. We need to talk about it now. But anyway, I just want to give you some background. And that'll do it. So getting into more specifically the data that is in games. I'm going to start by going back to one of our examples, the Final Fantasy VII example, because it's one of my all-time favorite games, and I played it for a very long time. Basically, I don't know if you can see this from the back of the room, but essentially what a lot of these games did is allowed you to equip your characters, right? If you're playing a role-playing game, you can equip your characters with different items in order to allow them to perform better. You can actually pick and choose what kind of character strengths you want to have your specific player have, and then kind of go from there. So in this case, there was several different ways of configuring your character. This is a little over the top, I think. Level 99 with everything maxed maxed out. I never got that far. But the idea is that you're applying equipment, improving your statistics and gameplay, and allowing for that process as you go forward. Similarly, you can't see that at all, I don't think, in the back. But the same is true in World of Warcraft, right? You start, and nobody claimed that they played it here, but if you did play it, you know that equipment is all the rage in World of Warcraft. It's all about collecting items, and the rarer the item, usually the better the stats are of that item. And so you can actually build a character and build all the information around that character and start kind of growing and evolving and making changes and attacking individuals and so on and so forth. This I like even more, so I want to make sure I included that. This is for, for all of the people that don't know they're nerdy, right? And don't know it because it's really a lot of the same thing. Each player has a different level of statistics, a different level of information that's associated with them. They have certain abilities, right? In a lot of these games, you can select, somebody who's either fast on their feet or who can catch really well, and you have to make a decision based on that and build a team in order to accomplish your goals and going forward. The other interesting thing that they have, I don't know if you can see it from the back of the room, is this notion of free agency. So you can actually go in and pick and choose and build your team and have basically a well-rounded experience, or you can not. You can make everybody fast and can't catch the ball, and you have a good run game, right? So it's all about how you piece all these things together and push it forward. I think the reason why I wanted to make sure I also included this is from Destiny. I personally haven't played it, but what I've noticed is as we started going through some of these screens, you can actually see some of the interesting analytics that are starting to be displayed as part of this process. And some of this data is being rendered in a way that we can more easily read it. And so what I've noticed in the enterprise is that a lot of interfaces are starting to look like this too, right? So there's kind of this convergence of data in the way that we interact with it. For example, everything is laid out in a way that makes sense and centrally located. Once you start clicking on any of these pieces of information, you can actually drill in and see what makes up that piece of information, right? Just like in, I don't know if anybody uses not graphics tools, but data analytics tools in the office. Basically, you see a number that looks weird, you click on it, and then you can actually see the underlying data, what's powering that information. So this is basically leveraging a lot of the same visual effects and user experience and providing a similar data experience. Before I go any further, I'll do one more.
Someone's gaming down there.
Yeah, I can hear it. It's Call of Duty, I know. Another one, I couldn't find a good graph on this online. This is taking it home. I don't know if anybody's played Mario Party. Yes. The latest iteration of it, I think probably several in the past as well. Basically, it gives you kind of an interesting graph of how your gameplay went as you were playing. So you can start to see where hearts were broken right here. Right? That's where, in this case, Princess Peach got ahead of the game, and it was totally not even a fair fight after that. So you can start to see and peel back and understand what's happening as part of the gameplay, and it's displayed in a way that makes sense. And I feel like this is one of those areas where there's, again, this convergence around having this very visible, very easy to understand data, and having the ability to kind of all choose your fate. In this case, it's kind of a recap. It's too late, it's over. But in many instances, there are things that you can change and interact with that information as you go. Now, I'm about to change gears a little bit. So in terms of kind of in-game data usage, are there any interesting examples that you guys can think of as you've been playing in the past, I don't know, 35 5-ish years. Looks like that's roughly 82-ish, 37 years.
So in Mario Party or even in Mario Kart, if someone's winning, the game changes to give other players advantages to catch up.
That's right, and that's actually an interactive gaming approach, right? It's somebody bringing in data and it's making changes in real time as part of that process. So that happens in, I feel like, most modern games where the AI will actually make decisions based on your position. Mario Kart is a big one because I feel like, at least as far back as Super Nintendo and Super Mario Kart, if you were in first place, everyone would be right behind you. But if you were in last place, you'd be able to pass people. So it's kind of this interesting interactive data model. Yeah.
I just want to know, like, this fantasy sport game, it's like on the rage nowadays. Like, what's behind that? Why do people play this kind of thing? It's not like Call of Duty.
It's gambling. That's the answer. But yes, that's a great. I don't necessarily. So the question was, what's up? What's up?
It's
The
not
question
really
was
mobile gaming.
legit. What's up with fantasy sports? Right, playing fantasy sports. And just so DraftKings is a local company. Is anybody here from DraftKings by any chance? I think that'd be an interesting kind of topic to broach. But yeah, I mean, it's similar to, if I go back, like this notion of having players that have certain statistics that are associated with them. There's a certain likelihood that somebody will perform a certain way each week, right? So the idea is that you're basically picking among roughly 12 of your friends who will be the best team and what will be the best way to play that week. So it's kind of an interesting approach. It's using some predictive, in some sense, some predictive analytics to make a determination how many points will be scored. I personally always trust the computer, but sometimes the computer doesn't know that somebody sprained their ankle getting out of a car, and then you end up losing a bunch of points. But
So how does DraftKings make money? Is it selling advertisement or on their website?
no. So the question again is kind of interesting. How does DraftKings make money? It's basically, as far as I understand, it's like going to the casino.
Oh.
So everybody puts down X dollars, and then there's a jackpot winner.
Then they take a percentage of the jackpot.
I would be curious to get the inside scoop on
The
DraftKings.
top 10% of people get paid.
Top 10. And the top.
Legally, you have to set the jackpot size ahead of time. It's not contingent on people playing. Like you can guess how many people play in order to data science and set the jackpot for a reason.
Right. You said the top 10%?
Yeah,
So the bottom 90.
lose their money, and that's how they make all their money.
As far as I understand, they're doing quite well.
Very well.
Which is great. So we talked through a couple of gaming samples. I'm hoping that one, I'm not going to be on until 8:30, so I'm hoping we can talk about more video games and how data is used later. But let's continue to grease the wheels here a little bit. I'm going to continue greasing the wheels. So there's a community called Giant Bomb. They're an online community. They basically report on gaming largely, and they have their own wiki, and they basically kind of build their own presence and brand. One of the things that they've started putting together is a player dossier. So basically what they do is they create a report on an individual based on all of the games that they're playing. And they do it in a very visual way. They actually incorporate At the time that I looked this up, they incorporated 3 different organizations in their gaming data. It was Blizzard, also known as Activision, Microsoft, and Valve. So based on your performance in these different gaming arenas, they actually put together this nice little visual of you so that you can compare yourself to other players in the game. And basically allow you to better kind of interact as part of their community based on certain topics. You can actually see, this is kind of an interesting, I thought this framework was a little bit on the interesting side, mostly because this is where a lot of the kind of data and analytics projects go, right? You actually you do a task, you do something. Then you validate, make sure that it was done properly. Then you provide additional context based on that, so you may bring in other different kinds of data. Then you analyze it and essentially share it, publish and post that information. So it's very similar to what happens in the enterprise using data. So I thought it was kind of an interesting way of kind of bringing that same topic and using it for video game players, essentially.
So professional video game players, or were they whose gameplay are they analyzing?
It's largely, I think you can just opt in. And you can give them your IDs and they'll do it for you.
Okay.
But the idea would be, yeah, it's like well-known gamers that are highly competitive and they can go and check it out. So another kind of practical example. This is actually, who's familiar with MapR? They provide Hadoop distribution. Basically, they recently signed a deal with Blizzard for Activision. So they wrote this great post. This is part mostly from it, but the different ways that they are using and leveraging data, basically big data, as part of the video game industry. There's 4 main tracks, and they're all things that you basically figure would be things that you want to leverage data for as part of the video gaming experience. 1, just analyzing the gamer's activity, their social presence. That makes sense. 2, tracking the player's stats, potentially versus others, and making some real-time changes like we talked about earlier. Obviously, the big one, and we talked about the high scores earlier, and making sure you get the highest score in Pac-Man, generating leaderboards for the potentially millions of people playing these games in real time. And then, again, we talked about it earlier, but changing the gameplay as it's happening and reacting to it. Who's seen the Mario project? 3. Excellent. So what I'm going to do really quickly is I'm going to talk through, because I don't think my laptop will overpower the jackhammer that's in here. I'm going to just talk through a couple of YouTube videos that are basically a walkthrough of the Mario project. What somebody's done is effectively done is creating a new series of machine learning that can actually go through and play, in this case, Super Mario World. It gets straight. Oh, great ad. Thank you. What you do is go through and play Super Mario. Basically, the idea is to get to the end of the level successfully. It uses a new framework. I'm actually going to explain this. That you may have seen earlier called NEAT. I have it on screen. It's called the Neuroevolution of Augmented Topologies. There's actually a huge white paper on it. If you're interested in it, I'm going to be providing the links to everything after this. You can actually see these are the different probabilities for touching each button and having that end in a successful way. So you can start to see, for example, pushing right is almost always a positive experience because that's where the input level is. And then you can actually see he's actually highlighting in the top left all the different things that the machine learning algorithm is actually seeing. So for example, obstacles, opponents. It's actually pretty similar to the Ms. Pac-Man scenario where we saw kind of the opponent and what the good thing to do, see an attack, what the bad thing to attack is. This is largely a probability, in a sense, a probability matrix. So you can actually see all the reds are where it would be bad, a bad time to press that button, and all the greens would be an opportune time to press that specific button. The whole idea of this neuroevolution of augmenting topologies is basically this. It's about the evolution. I'm sorry. I feel like that's a little intense. He's basically going through each button and when things work and when they don't. The idea is that you can actually create, it's in evolutionary term, there are different species of this algorithm that work either successfully or unsuccessfully. And so that's where that matrix that you saw at the top starts to get built. And so it basically learns based on what is good and what is bad. And over time, you can basically evolve the algorithm to successfully complete a level, in this case, for Super Mario. As an augmentation of that project, they actually went ahead and did the same thing for what we were talking about earlier, Mario Kart, right? In this case, it was kind of, it was a lot more interesting, I thought, mostly because it took less attempts, which I guess you would speculate is correct, right? If you're trying to loop around the track, has anybody seen this before? It's really it's a squatty bike, just so you guys know. So these, just real quick, reviewing the information from the last time. But the idea is that he's going around this track. Initially, what he did was he created a time trial track, which in Super Mario Kart, you may know, doesn't have any opponents in it. So it's kind of like the dry run, basically to try to teach you to go around the track successfully. There are times where you can actually see this as kind of the evolution and the idea of that species, the series of species going through this. There are some, he's showing now, there are some times where it was basically doing the wrong thing the whole time. If you do the wrong thing the whole time in a race, it could be pushing the right directional arrow. And if you just hold the right directional arrow in a racing game, you're not going to go anywhere, so you're not going to be able to accelerate. So that was part of this process. You can actually see that it's also not all that aware of which direction is the right direction to move in. But the idea is that each time it performs better, it's kind of a thumbs up. And each time it performs poorly, it's kind of a thumbs down.
Fitness measure?
I didn't read enough about it in the paper, to be honest. But it kind of, it plays into the whole evolutionary component. It's kind of a part of their terminology. I'm sure it's some coefficient that. So you actually see, I think if we had audio, we'd be able to hear it, but it basically only took like 16 attempts. Versus in Mario, it took well over 40. So it's kind of an interesting way of going about it. Then by the time the training was over, it could basically complete the track in 2 minutes, which was first place for one of the difficulty levels. So it's kind of an interesting way of using machine learning. So it's kind of an interesting way of using machine learning to kind of accomplish your goal. Using data as input, doing some machine learning.
Do you know what kind of raw data it's acting on? Is it taking into pixels or?
I think it's only based on button feedback and whether or not it accomplished its goal or not.
How does it know it's accomplished its goal?
I believe that's a. believe that's a person-driven operation. So basically, once it's completed the track, then it gets a thumbs up. And if it kind of sits installed and never actually accomplishes anything, it's kind of, yeah, that's right. It's classification with a little spin on it. Anyway, I can watch this stuff for like way too long. You can actually see the buttons it's pushing. I don't know if you guys caught that on the top. We see you basically he won after a few tries, which is pretty impressive. I know some people that play Mario Kart somewhat competitively, and after showing them this, it's just like, hey, it only takes a computer 60 tries to play. Are there any? So I used a couple of examples. Does anybody else know of some interesting machine learning projects that are based on video games?
So there was a paper a little over a year ago from DeepMind using reinforcement learning and long short-term memory neural networks, because they Q networks, they're using the context of reinforcement learning to play, I think it was 15 or 16 different arcade games, taking in only as their input pixels of the image, and then using the score as a kind of your error function that you're evaluating against. And then there was varying degrees of success for, like, depending on how strategic the game was.
Yeah, I think that's. I went into the Ms. Pac-Man example kind of early. I think that's an interesting one because there are things that are clearly good and there are things that are clearly bad. So allowing a machine learning algorithm to kind of go through that makes it interesting and almost more accomplishable because there is a strategy, but overarching it's like this section's good, this section's So just throwing some more data at you. This is like, I wanted to bring this up because I thought it was really interesting, just examining the industry as it exists today. Basically, I don't know, this is pretty big news. It's from like a weekish ago. Activision, publisher of Call of Duty, and they also have World of Warcraft by acquisition. Blizzard acquires King, right, creator of Candy Crush, the free game everybody has on their phone, for $5.9 billion, right? And I put in some comparative numbers in there too. Again, video game related, where Amazon acquires Twitch for about 1.1, and Facebook acquires Oculus for about $2 billion. The reason why I think this is so interesting is because Candy Crush is a very data-driven organization. They know how to get people to download. They know how to keep people enticed. They know which interactions are successful for them, especially in terms of the micropayment economy. I didn't ask. I assume everybody has it, but show of hands, Candy Crush players? No way. 1.5? That's none.
I installed on my phone, but I opened it for 5 seconds and couldn't understand it.
I just want to get hooked.
$5.9 billion. Well, I guess for the amount of people there in this room that aren't playing it, that was a pretty big deal for King. But yeah, I mean, it's just the state of the industry. The more data-driven you are, the higher value you are, right? Because you can make decisions based on data. And just to wrap up, we can have more video game related conversation because we're going to be here for another hour, which is awesome. But just wanted to let you know, I basically talk about, my big thing is the big data of everyday things. I like using everyday examples to explain big data in a way that makes sense. That is inspired by The Design of Everyday Things by Donald Norman. It's a really good book. If you haven't read it, I love the cover. I usually post it. It's a picture of a teacup with the handle and a spout on the same side. And it's used in a lot of human-computer interaction courses and things to basically get you to think a little bit better about how people are using your software. But that's it. If you have any questions, let me know. If you have any comments, let me know. If you want to contact me, there it is. I'm here. We're here for the next hour or so. So let's talk about video games and data, or talk about just video games. Totally up to you. Thanks.